so that you can take a look at these for your test and help you out. So first of all, we need to know what a force is, and we know that it's a push or pull, and what forces do is they can make resting objects move, and it can also cause moving objects to slow down or stop moving or to change direction. And um, we know that that's what a force is. It can change an object's speed or direction, which is also is acceleration. Remember, acceleration is speed with direction, and that is on the test, just so you know. What a force is, being a push or pull, is also on the test. And how do we measure it? We measure it in newtons, and that is on the test, that is the unit that you need to know. We talked about it being able to move something that is 1 kilograms in size across a meter stick in 1 second. And of course, it's named after the scientist Sir Isaac Newton. There are two types of forces. There are contact forces and non-contact forces. Those are the big umbrella forces. Those are the big um, units, and then we have different types under them. So contact forces, also known as direct forces, and when objects touch each other. An example of that is friction. Example of that is when you walk across the floor, when you ski down a slope. Any of those things where there's contact. When I hold a wagon and I pull it, all contact. Non-contact or indirect forces act upon something without it touching. So things like that are static electricity does that. You go to reach for it and it zaps you before you actually touch it. That's one. Another one is magnets, being able to move things across. Those are all examples of non-contact forces. Also, electrical forces and electrical forces are attracted to each other, but magnetic forces and gravitational forces, all examples of non-contact forces. One really great example of a contact force is friction, and it's friction between two objects. So like when you rub your hands together, rub two sticks together, wheels on a tire, ball rolling around slows things down, and it is a force that opposes the opposite thing. You need to know that because that friction is on your test. It includes objects that are touching on solids, but also things that pass through liquids and gases. You can still get that friction through those other states of matter. So what do? We draw what are called force diagrams. And force diagrams use arrows or vectors to tell us what direction the force is going in and how much it is based on the length of the line. So the friction, for this example, this guy's going down the hill. The pull of gravity is going in the downward motion. The rope is pulling up, and if I would have two ropes, I'd have two ropes going up here. Then I also have the pushing off of the cliff and the friction of my foot on that cliff as I go down in this picture. And that's an example of a free body force diagram. You need to know how to make these for your test. You're going to practice some more too. Another example here is that I have a rock on the ground. The red arrow pointing down is going to be the gravity working on it. The arrow going up is the ground pushing back up, or the normal force from that ground. And that's if that rock was sitting there and not moving. When I take that lever, I'm pulling down on there to make it move. But if I'm just talking about the rock resting there, you need to know that it's gravity and the normal force of the ground up from above. Now, we do know that if you go into this force diagram activity here, that it does a really nice job of explaining exactly how to construct these. If you are having any difficulty whatsoever in constructing these, you want to go back and you want to look at these examples. They will be great examples for you to help you on the test. Okay? So it's important that you go back and you look at those if you are having difficulty with them. And you do that just by going back through there. Uh-oh, I lost my notes, so we better go back to them. All right, so building force diagrams. So make sure you know how to do that and you can practice that. Next, we need to know what net force is. You need to know what net force is, and you need to know how to calculate it. The definition is on the test, and how to calculate it is on the test. So you add all the forces involved. Balance force equals your net force is 0, and you have no movement. Unbalanced means that you have movement and that there's acceleration going on. Both of those terms are on the test. You need to know what those are. Those arrows that we're talking about when we're doing this net force, etc., those arrows involved show the magnitude and the direction of force. You need to know that gravity works downward towards the center of the earth. It's a very powerful force that does that, and it's a non-contact force. This Khan Academy gives you a lot of good information about that, and you can take a look at that. You need to know Newton's 3 laws and examples of Newton's 3 laws. If you go into GradPoint, there's some great examples of Newton's 3 laws. The first law is the law of inertia, and it says that things at rest are going to stay at rest, and things that are moving want to keep staying moving. And when you ever have a net force of 0, that means your things are at rest. Newton's second law is acceleration equals mass divided force divided by mass. Or you can say force equals mass times acceleration also. And the third law is for every action there's an equal and an opposite reaction. So you really need to know good examples of all three of those. Different things, different scenarios that would be things that you would be able to say that is first law, that second law, third law. So kind of refer back to that Olympics that we did for that. Now, this is a great little YouTube video about the 3 laws, so, it makes you laugh. So if you're having a little bit of trouble studying right now would be a good time to look at that and take a good laugh about it. All right, so that's your force notes, and hopefully that will help you study for your tests coming up.